Welcome to the tutorial for BIM WIZARD, Knauf's powerful and easy-to-use plugin for Autodesk Revit. Let's jump right in. Once you download and install our plugin, you can find it on the Add-ins ribbon. You'll notice the initial screen has a bit of text instructing us to select a wall or ceiling type. So let's do that. Here are all the different wall types we have available in our product catalog. If we select a system here, the database will load and the rest of the tool becomes available. You can see the interface is broken into multiple distinct areas. In the upper left is the performance criteria area, where we put in information about fire and acoustic ratings, physical dimensions, and framing details of our system. In the attributes area, we can specify impact, moisture, and mold-resistant linings for our system. In the ancillary area, we can search for a system by name, and specify up to 3 linings we want systems in our search results to have, or not have. Below that is an area for acoustic ceiling tiles related filters. In the top right is the helpful links area. These are just a handful of hyperlinks to popular areas of the Knauf website. Along the bottom is the results area. For any particular set of inputs from the filter area above, we'll get results meeting the minimum specifications we've provided. We can expand any system for further information about it. We get a 3D thumbnail image, full system description, and maximum wall height or ceiling span details. If we want to better view and compare results, there is a button at the top to minimize the filters area. We can open multiple systems at a time if we like, and compare. Let's examine some of the individual filters. Under fire resistance, we can select non-fire rated, non-load bearing 30 up to 180 minutes and over, and load bearing 30 up to 180 minutes and over. If we select non-load bearing 60 minutes, then we can check in the fire resistance column that everything is non-load bearing 60 minutes or above. Under acoustic rating, we can search by RW or RW plus CTR. If we put in 45, we can check that everything in the acoustic column has an RW plus CTR of at least 45. If we switch the button back, we can see it's now an RW of at least 45. For some ceilings, we can also search by LNW or LNW plus CI. Under width, we can specify the maximum outer dimension of the system. If we enter 140 mils, we can check the width column to see that all results have a footprint equal to or narrower than 140 millimeters. In the height span field, we enter how long our framing members need to be. Based on this and the pressure selected above, we'll get a minimum stud arrangement to achieve the height we specified down in the expanded results, along with an updated maximum height. This first system has 76 mil 0.55 base metal thickness studs at 600 centers, and a max height of 4130. If we nominate 4131 mils, we see the stud spacing has decreased to compensate and increased our max height to 4530 mils. But maybe we don't want more studs and would prefer thicker BMT studs. Then we take this box to keep our stud spacing at maximum. Here we can see the BMT has increased to compensate. Now maybe we don't want thicker studs either, in which case we tick this box, and now the stud width has increased. So you can see we have very tight control over what our framing is doing here. We can use the stud width filter to narrow results according to the width of stud used in a system's framing. The framing configuration filter helps us specify a system's framing layout where there are 2 framing layers of various types. For example, an independent stud on one side of a fire barrier and direct fixed linings on the other. Below are some inactive filters that don't apply to this system. These will activate when the appropriate masonry, column protection, or ceiling system is selected. If we need to specify attributes for our wall linings, then each side can be done individually. If impact resistance is selected, we will get high impact boards like Multistop 3 on one side. If we tick the other side and add moisture resistance, then Multistop 4 appears. Maybe we need mold resistance as well. Now we see Multistop 5. If we're sure we don't need any of these options and just want to thin out the results, there is a box labeled Not Required. This will remove any system with impact, moisture, or mold resistance from the results. Please note that using this may actually remove the most acoustically appropriate system from your options, so that's something to keep in mind. This is a good time to mention the Reset All Fields button. Naturally, it sets all filters back to their default values. If you wish to find a specific system and you know the Knauf system number for it, just type it in the system number field to narrow results accordingly. Sometimes you may want to only see solutions that contain a particular lining or set of linings. If we select Firestop in the first linings filter, we get only systems with at least one layer of Firestop. If we select multi-stop in the second linings filter, we get only systems with both firestop and multi-stop. If we then choose Exclude on the first filter, we get only systems that have multi-stop but not firestop. Let's select the ceiling type. Since this is a ceiling on a concrete floor, the masonry filter has activated, so we can select the slab thickness. We also have the ceiling fixing type filter, where we can choose between direct, furred, or suspended fixings, and the flooring type filter with various flooring options. If we select spanning ceiling, we can see the ceiling span filter and checkboxes are active again. Let's take a look at how the acoustic ceiling tiles work. They have their own area where we can filter by edge profile, NRC and CAC acoustic values, light reflectance rating, or percent recycled content. We can also search by tile width and length in the performance criteria area. Please note that the longer side of the tile will always be considered the length here. An interesting thing to note about the results is that they are ordered by an economic ranking system. So for any given set of inputs, the most economical solution will be at the top of the list. This has two main benefits for us. First, we know we're meeting all building codes and standards for the given specifications, and second, we know we're not over-designing either. This allows us to easily achieve the perfect balance between safe design and efficient design that can only be achieved with quality, manufacturer-generated BIM content. Once we've selected a system to export to our project, we have two options to make this happen. First is the Save to Revit button. This will add our selection to a queue that allows us to continue searching through our results. When we return to Revit, the systems will generate and be available in the wall library. Here are the two inner wall systems we just selected. The downside to this option is that we have to find our systems after we've imported them. If we want to avoid that, then we'll want to use the second button, Draw in Revit. This button will also export your selected system, but when you return to Revit, the Wall tool will engage with your selected system as the active wall. This also works with ceilings. However, it will activate the Ceiling Sketch tool and will need to define a ceiling boundary. If, instead of generating a system, we want to save it for later, we can simply right-click any result and select Save to Folder, then indicate which folder to save to. We can access those folders anytime by clicking the Folders tab. From here, we can organize our folder tree, send systems to Revit with the Save to Revit or Draw in Revit buttons, or even send a whole folder to Revit. If you are in the early stages of your project, consider using the Solutions tab to find suitable systems to get you started. You only need to select building class, number of levels, and framing type to receive a list of acceptable systems for various wall and ceiling categories, all tagged as recommended, most economical, or high performance. Just like the main BIM Wizard screen, any system here can be saved to Revit or your folders. Let's take a look at what we've generated. We've got a few Knauf systems here, including an exterior wall with cladding, a masonry wall, and a party wall system. If we take a look at the family type properties of this basic steel stud wall here, we'll see it's packed with useful information. First, we see the Knauf family naming standard. It's ANZRS compliant and designed to make similar systems grouped together in your library. These families can, of course, be renamed according to individual company standards. All of our type parameters are grouped together into categories that intuitively make sense. Under constraints, we have maximum wall height or ceiling span information, along with the height limiting factors and applicable load-bearing notes. Under construction, we have the basic function of the wall and whether or not it's discontinuous. In other areas, we have information about impact, moisture, and mold resistance, framing dimensions. Further down, we have the system's thumbnail image, unique model number, physical description, full fire rating. This includes load-bearing and non-load-bearing ratings with their direction and fire rating basis. Below, we have GICA green tag information, acoustic ratings, basis, and notes, and some general contact information. Now let's have a look at this wall structure. The first thing we notice is that the thickness of all lining materials is repeated in the name of the material used. This crucial feature becomes important in material takeoffs, as we'll see later in this video. The second thing we see is how the framing material is named. Although we won't see the cross-section of the studs in our plan views, we'll still know the specific stud arrangement needed to achieve our desired wall heights, since it's instantly documented in both the family parameters and the materials themselves. The third thing we see is that insulation is included as its own material and given a specific name. Again, this setup will help in the material takeoff later. In the material browser, we can again find a wealth of information. For each Knauf product, we get a system description right out of the brochure, available sheet sizes, and a link to that product's page on the Knauf website. We can also find each product's real physical and thermal information. This allows us to run more accurate energy analyses than is possible using generic gypsum properties supplied by Autodesk. If we want a quick and easy way to show all of our new systems, there are wall and ceiling Revit schedules available for download on the BIM WIZARD landing page of the Knauf website. To bring the schedules into our project, we simply go to the Insert ribbon, Insert from File, Insert Views from File. Then navigate to the download location and find the schedule RVT file. If we drag the wall schedule into our sheet, we see all our new systems populate into it perfectly. This gives us thumbnail images, system descriptions, ratings, wall dimensions, and so forth. We also have separate schedules for our plasterboard and acoustic ceilings. You can, of course, customize these schedules or create your own. Material takeoffs are quite easy to make in Revit. If we look at this simple one, we can see that adding the thickness of each material to its name has paid off for us here. We're getting separated quantities for linings of the same name but different thickness. Without that feature, these quantities of 13mm and 16mm firestop would be lumped together, and our contractor wouldn't know how much of each to order. We can see our framing, masonry, and insulation have also separated by type, giving us more detailed quantities than we could otherwise achieve with generically named materials. Since our insulation is modeled as a zero thickness layer, its volume won't register, but we'll still get an area that's distinct from our framing, cavities, and substrates. Going back into BIM WIZARD, there are some useful tools in the Options menu. In the Wall and Ceiling Type Name tabs, we can alter the Knauf naming standard by removing Default from the active fields and adding any combination of custom text and dynamic fields. The preview field below gives a sample of the new naming system. This system can be exported and archived, then imported later. It can be reset to the Knauf default at any time. In the Folder Options tab, you can export the entire folder tree, including all systems saved within, for archiving and import later. In the Material Replacement Master tab, you can specify which of Knauf's generic materials you want to swap with one of your own from the active project. Going forward, BIM WIZARD will always use your material unless it can't be found in the active project or if you remove the assignment. Your entire replacement schedule can be exported and imported later by any BIM WIZARD user. I hope you found this tutorial helpful. Additional content, including a user guide, is available on the BIM WIZARD landing page. Keep an eye out for the many new features we have coming soon through BIM WIZARD's automatic updater.